In this video, let us look at absolute value inequality. Absolute value inequality. Now, solving absolute value inequality combines two ideas: solving the absolute value equation and then solving the inequality and writing the answer in set builder or interval notation. So when we solve the absolute value inequality, the first step that we do is we solve for the absolute value itself. And then we will get one of the two possibilities. So here, the first possibility is the absolute value may have either greater than or it may have greater or equal to. These types of inequality are called OR. OR. On the other hand, we could have, when we solve for the absolute value, we could get either less than, we can also get less than or equal to. These are called AND. Now the difference is when we get, if we have the AND, that means we look for the place where, look for place that is true for both equations. Inequalities, I apologize, for both inequalities. Yes. So we're looking for the place where the first and the second is true. For the OR, and what that means is the final answer is the place where the shading is crossed. For the OR, we'll look for the place where either one inequality or the other is true. One or the other inequality is true. And that means that the final answer is going to be everything that is shaded. So this is the main difference between solving of the absolute value equation or inequality. So let's try one example where we will solve the AND. So we'll begin with the AND. So here is the example. Let's solve 3 plus absolute value 2x minus 1 less than 8. So we have seen a similar setup in the different video. The only difference is now with the absolute value, we have the less than symbol as opposed to the equal. So the first step is the same. We solve for the absolute value by minusing 3 from both sides. That makes absolute value 2x minus 1 is less than 5. Now at this point we note that we have less than, and so our setup is of the AND type. So we have AND. Now once we have noticed it, we are going to split our inequality into two different parts. The first is exactly the same as what we see, but without the absolute value symbol. So 2x minus 1 less than 5. The other is 2x minus 1, but the other side is the inequality is flipped to the opposite and the negative and the sign of the number is also changed to the opposite. So instead of the less than, we get greater than, and instead of the plus 5, we get minus 5. We can discuss why that is in a different video, but for now let's just continue and finish this. So to finish, we undo all the remaining operations following the order of operations PEMDAS, and we undo the -1 by adding it to both sides. That makes 2x less than 6, x less than 3, because once we divide both sides by 2, 2 goes into 6 3 times. So that's the first half. The second half, we repeat the same process, adding 1 to both sides. That makes greater than -4, dividing both sides by 2 makes x greater than -2, and that's our second half. Now on the same coordinate axis, on the same sketch, let's plot both of these and see what it tells us. So here are the x-axes, and what does our answer tell us? Hold on. So here is back. So the 3, one of them says 3, one of them says -2. Well, -2 is going to be somewhere on the left side. 3 is going to be somewhere on the right side. I do not have to be very precise. X less than 3 means everything to the left side of the 3, that is less than 3, and I continue shading all the way. Now, for the greater than -2, that means starting at -2, anything to the right. And so I continue shading everything to the right. Now, since I have the end, my final answer is the place where the shadings intersected. So what I look for is, I look for the place where the shadings crossed, which is here. So this is going to be my final solution. And in the interval notation, all I need to do is copy this diagram over, and that's already the answer. Parenthesis, -2, comma, 3, close parentheses. We have parentheses as opposed to brackets because our original inequality has no equal sign. So if we had less than or equal to, we would be getting brackets as opposed to parentheses. But because we do not have an equal sign, our corner points, -2 and 3, are not included. So we get parentheses. And this is the answer in the interval notation. Now, to write it in set builder notation, all we do is we use our answer from the last line here, and we add the set builder notation to it. So in set builder notation, the answer would be curly parentheses, which means the set, and then x, because that's what we have inside the set, and then the two conditions: x is greater than -2 and x is less than 3. And that really is all there is for the set builder notation. So this is how we solve the inequality of the and type. We'll look for the place where both of the sides, left side and right side, both are true, and that is the place where the shadings crossed. That's the end for that. We could also check the shading with a calculator. So if we go back to the very beginning, to our original inequality, let's type it in the calculator and see if we can verify this answer. So here is y. Let's type in 3 plus, then to get absolute value we can go to the math, scoot over to the NUM, that's numbers. First choice is absolute value, enter. 2x minus 1, and then under the math we have test. So if we have second math, then we can go to the 5, which is less than, that's the symbol we have, and we'll put in 8. So now let's see what that does. Here is the diagram. Looking a little bit closer, we can see here, we can see that there was nothing, and then there is a line that's going from -2 to 3. because this is this window goes from -10 to 10, counting by ones. So this is -2, this is 3. Now what does that picture mean? Well, what that picture means is actually exactly the same as the sketch that we have here. This sketch is the same as the diagram we saw. So just to illustrate, what we saw is coordinate axis, and then each time our inequality was true, the calculator plotted 1. Each time it was false, the calculator plotted 0. So what we see is we see zeros, which means false, all the way here until we get to the -2. And then after that it was true. Everything was true, true, true. And that's the height of 1. This is 1. Until we got to the 3. And after that, it was back to being zeros or false. So that's the diagram we saw, and it's exactly the same diagram as we see here. The solution is between -2 and 3. We don't see parentheses versus brackets with a calculator, but we can see it that it should be parentheses because original inequality does not have an equal sign. And that's all for this video. Thanks a lot. Take care.